Welcome back to What is 5G and how is it measured correctly? Now, in part 3, we want to look at how 5G and the associated technologies affect the measurement of field strengths. Let's first look at the protection of those who install and maintain antennas or who have to move around on rooftops and towers. They get the closest to the antenna. As humans do not have a sense that detects electromagnetic fields, so-called personal monitors take on the job of warning us of excessive field strengths. Generally, there will be several transmitting antennas located together on a rooftop or tower, and all of them need to be considered. All national and international standards are clear on this point. The sum of all the field sources is what matters. So the personal monitor must cover a range that starts with broadcast radio frequencies, that is below 100 MHz, and that goes up to at least 5G frequencies as the upper limit. The rollout of 24 to 30 GHz 5G networks with relevant output power is not far off, so the personal monitor should cover up to 30 GHz or even above this frequency. The modulation and crest factor of a 5G signal poses no problem for the Redman 2 and Nadalert S3 personal monitors, though they are completely suitable for this application. Safety zones are defined and fixed by calculation or simulation. If the system is capable of beamforming, a simple measurement using a broadband or selective measuring device will not be of any use if the system has not first been set to a defined state. The first step here could be to deactivate beamforming. However, you should not forget that the sweep range of beamforming is often greater than the area covered without it. So it is better to operate the system with beamforming in a defined state, at maximum output power and maximum antenna gain, that is, directivity in all directions, and to determine the field strength using the max hold function of a field strength meter such as the Nader MBM or SRM. When equipped with the appropriate probe, the MBM as a broadband field strength meter is capable of measuring signals up to 90 GHz, which is more than enough. The selective field strength meter SRM 3006 can already handle frequency selective measurements on installation up to 6 GHz. This is fully suitable for the initial rollout phase of the 5G network. NADA has a new antenna in the pipeline that will enable existing SRM 3006 devices to measure the frequencies between 24 and 30 GHz that will be used for the second stage 5G rollout. We will look at possibilities for code selective measurement and extrapolation with the SRM in part 4 of this video. Environmental protection, in other words measurement that concerns the general public, generally demands that every field source is measured, without any exception. A good choice here is to use the NBM with its probes that cover the range from 0 Hz to 90 GHz. The SRM 3006 can make frequency selective measurements from 9 kHz to 6 GHz. We have already mentioned the extension of the frequency range. Both the measuring devices capture the instantaneous field strength, not the maximum possible value. If you want to determine the maximum possible field strength, the use of extrapolation for mobile communication system has proven useful and is even mandatory in many countries. To do this, the SRM makes frequency and code selective measurements of the traffic signals and then extrapolates these results to give the maximum possible radiation level for each of the mobile communication services. A small trick is needed to make a frequency selective measurement of the instantaneous field strength of a 5G service. As you know, 5G systems below 6 GHz can have a bandwidth up to 100 MHz. The SRM 3006 has a maximum bandwidth of 20 or 32 MHz, depending on the operating mode. To make a correct measurement of a 5G service despite this, you can use the safety evaluation mode of the SRM. This corresponds to the channel power measurement function that you may know from other spectrum analyzers. However, the SRM can make this measurement isotropically and can also measure and display dozens of such services simultaneously. The easiest way to do this is to create a list of services using the PC software supplied. In this example, we have defined a 5G service called T-Mobile for the 3.5 GHz to 3.6 GHz band. During the actual measurement, the SRM in this configuration automatically makes a level measurement with a 20 MHz bandwidth every 10 MHz in the specified band and adds the results together. The result is a field strength for the service. This is shown here, for example, as a display of the current maximum or minimum power level within this time and frequency window. This kind of service can be combined with any other services so that you can get an overview of all the services within a few seconds. If you want, the result can be displayed directly as a percentage of the standard limit value, as shown here. However, you do need to remember that the introduction of TDD means that the handset and the base stations no longer transmit in different frequency bands, as this was the case with FDD, but in the same band. This means that the displayed value with TDD is a sum of the emissions from the provider's base stations and all the handsets that are in the vicinity. If you want to distinguish between these values, you can analyze and evaluate the signal in the time domain using the SRM 3006 and the scope option, for example. It is even easier to use the modulation option for the LTE TDD, which can distinguish between the base station and the handset. Another approach is to continuously measure the exposure by means of a so-called area monitor. Such broadband or selective measurement devices record the exposure level 24 hours a day, 7 days a week, and publish the result on the internet. They are also capable of transmitting an alarm if the limit value are exceeded. This approach is being used intensively in Australia in connection with 5G, for example. So far, we covered every application. You can say that neither has the right solution for every situation. The only thing that is still missing for the extrapolation to the actual maximum exposure is 5G mode for SRM. We will examine why this is so in part 4.